I'm Dave Kadich, Lineman and Regional Fall Protection Coordinator for the Desert Southwest region. In this video, we'll outline Western's response to the new OSHA Fall Protection Standards. With me today is James Hill, Lineman and Regional Fall Protection Coordinator for Sierra Nevada. Shane Bender, Lineman and Regional Fall Protection Coordinator for the Upper Great Plains. And Jason Wenches, Lineman and Regional Fall Protection Coordinator for Rocky Mountain. Together, we'll help explain the changes and what impact they'll have on your crew. Across the industry, falls from elevated work positions on transmission and distribution structures still continue. Western's leadership remains committed to our role as a safety leader and innovator in eliminating workplace falls from height.
Thank you for taking the time out of your busy schedule to watch this video and learn how to comply with OSHA's new fall protection standards. The safety of Western's employees is my #1 concern. This is not lip service. The work that is done on transmission systems regularly ranks as one of the most dangerous jobs in the world. Western has a long and proactive safety record of which we can be proud. Our incident, injury, and lost time rates are below the industry averages. However, we know we can do more. I am excited at how Western, through the Fall Protection Committee, has embraced OSHA's new fall protection standards and served as a leader for the rest of the electric utility industry. I expect everyone, from the foreman to the apprentice, to fully adopt the fall protection requirements. At the same time, we must move beyond the notion that if we do a good job with complying with the OSHA regulations, we will have a safe organization. We need to get past the legalistic regulatory view of compliance and honor the spirit of safety, where safety permeates the culture of our organization and our industry. These new rules represent a major change in the way your work has been conducted for decades. That does not, however, make past safety practices bad or wrong. Safety is constantly evolving to incorporate new technology and better ways of doing business. There is always room for improvement to make our jobs safer. Complying may take more time and may slow work down. That is okay. I am fine with delays to keep our people safe. Equipment can replace and power revive, but a life cannot. As important as the work we do to keep the lights on and the power flowing, the most important thing we can do is ensure everyone goes home safely to their family at the ends of the day. Thank you for everything you do for Western, our nations, and the customers. If you have any thoughts about this video, fall protection, employee safety, or any other topics, please do not hesitate to contact me. My door is always open.
OSHA has made significant changes to both General Industry Standard 1910-269, commonly referred to as the Maintenance Standard, and the Construction Standard 1926 Subpart V. 100% attachment while climbing and transitioning obstacles is required in both standards, and now applies to both wood and steel structures. So, the long-standing qualified climber exemption rule that allowed linemen while climbing or changing work positions to do so unattached no longer applies. In the new standards, OSHA allows the utility industry 3 different work methods to achieve 100% fall protection for an employee working at heights of more than 4 feet on a pole, tower, or similar structure. They are work positioning, fall restraint, and fall arrest. Work positioning is a body belt or harness system rigged to allow an employee to be supported on an elevated vertical surface, such as a utility pole or tower leg, and work with both hands free while leaning. Under the new rules, it must be rigged so the user can fall no more than 2 feet. Wood pole fall restrict devices such as the buck squeeze and cinch lock meet the new requirements. Fall restraint is a fall protection system that prevents the user from falling any distance. In practical applications on wood poles and towers, this method is very limited as it would restrict all vertical movement. Fall arrest is a system used to arrest an employee in a fall from a working level. With a fall arrest system, a climber has full access and mobility, and in the event of a fall, the system will safely arrest the climber. OSHA requires the system be rigged so the climber can fall no more than 6 feet. Utilities and electrical contractors, along with support from the International Brotherhood of Electrical Workers, have been moving steadily forward with wood pole fall protection over the last several years. Equipment vendors have been engineering and developing different types and configurations of wood pole fall restrict devices to accommodate the needs of individual climbers. Today, use of these devices can be found throughout the utility industry. So now let's take a look at what changes OSHA requires for wood pole fall protection. OSHA states in the preamble that work positioning is for vertical applications only, such as poles and tower legs, and is not suitable for horizontal applications like cross arms and tower arms. OSHA specifically mentions in the preamble using work positioning on cross arms as inappropriate. So what does this mean for Western's linemen? A fall arrest system is now required when accessing cross arms. As we learned earlier, the use of a full body harness is a required component of a fall arrest system. A lanyard or SRL will need to be attached back to the pole. Of all the rules in the new OSHA standard, the use of 100% fall protection on steel towers has proven to be the most challenging. Last year, Western held a national fall protection symposium and invited utilities from all over the US and Canada to meet and discuss methods of 100% attachment on steel towers. It was clear there are no easy solutions. The symposium members generally agreed that using a life safety rope attached to the top of the tower and having climbers attach and climb with mobile fall arresters was a workable solution. Of course, that solution is one small problem. How do you get the first man up the tower to install the lifeline? To answer that question, it's necessary to understand what components of a steel tower are suitable for fall arrest anchors.
With a light loading tower, you can have the most risk of being attached to a member that's very small, which is going to be your worst problem. If you're in a medium loading zone, you got a little better member, and if you're in the heavy loading zone, you're better yet. In that consideration of the light loading zone, if you're on the suspension tower, you're on the lightest possible tower that Western has. So that one there is going to be the most risk for you. If you're up on the bridge, attached up there, your best possible connections are going to be right there where the leg comes straight up to the ground wire peak. Anywhere in there, you got a lot of bolted connections, everything is really strong. Once you get out on the arm now, there's where the risk starts increasing. Obviously, you're not going to be attached below yourself, which is the strongest member running right on the one you're standing on. So the member that's above you, that one there is going to be a problem. Every one of the light loading towers, that member there is actually a tension member. That tension member on a suspension structure is not made at all for any kind of attachment, and it will give. You'll know that when you attach it. It's going to be moving all over the place. It's not very big. It doesn't even look strong enough most of the time. Because all it's made for, like I said before, the tension member is like a cable. That's what it's made for. It's not made for you to attach to. So if you attach to the center of that member, that's your maximum risk of, if you fall, of that thing breaking and ripping right off the tower. Because it's just not designed for that. So that member there is going to always be a problem, and the only safe place to attach, unfortunately, probably backwards connected to the tower, which might be far away, and you really don't want more than one person attached to any of that member at all. With two people on there, you really got a lot of problems, and if somebody falls, both of you are going to probably go because that member's just not going to hold. Across the bridge, you have a lot more options because all the horizontal members on there, even though they are a tension member across the top, they've got a lot of bracing. They're not very long, and they're actually a lot bigger member normally than that one was on the end of the arm. But you do have to watch when you're in the middle of those members sometimes. If on certain towers, they may not be very big, especially on the square arms maybe where you got two of them versus a triangular arm at the top where you might have a single member. That one's obviously going to be heavier, so you'll be better off. That's across the bridge. So you got the end of the arm and across the bridge. Going up the ground wire peak, you got to stay right there along the edge of the leg member on that connection. The members at the bottom are going to be longer, so that first one up is the biggest one. That's going to be the riskiest one probably going across. You want to make sure you stay at the end of that member too, and keep going up the leg on the rest of the step bolts. The same as before with the step bolts, you got to be careful on those attachments on the step bolts, because on the end of those step bolts, obviously you have no sense of fall protection on any of those. They're just made for climbing. Once you get to the top of the tower, you can attach anywhere up on that top piece up there on the overhead ground wire attachment. There's a lot of bolts up there. If If you can find something to wrap around the members, get more than one. If you have to take the ground wire off or whatever it is you're doing up there, if you can't find a spot up there like that, there might be an extra hole on there sometimes. It's a working hole that we put on some of them too. If you can attach to that one, that's a great member. All of those attachment holes were designed for a minimum of 5,000 pounds just to pick up the ground wire. So they're not going to have a problem with those holes if you find an open hole up there. So if you have a suspension structure in a light loading zone, you have a lot of members that are small you have to worry about and how you attach to them. Those members, you shouldn't be attaching in the middle of them. You should be attaching as close to the connection as possible. And if I had to pick which would be easiest, I would say the connection that is attached to the biggest member, because that would be the safest spot.
So let's take a look at a few of the options for first man up. James, what are some of the options that we've developed?
One of the options that we're going to use is the buck hook, where the buck hook is attached to a long stick, which will be attached to the climber via an SRL or a rope with a mobile fall arrestor, and the climber will attach that to the steel anchorage as they ascend. Another type of equipment that we're going to use is the Y lanyard. We'll be snapping into engineered anchorages on the structure to ascend the tower. Another version of that Y lanyard is this one right here that'll have steel or aluminum hooks. Another option that climbers are going to have is using a Y lanyard attached to the harness and using bigger pelican hooks to attach around the structural steel members.
So another method we have is lead climbing. Can you show us a little bit about that?
Yeah, lead climbing is where a belay device is anchored to the structure and it keeps the climber attached through a rope system and anchorage points every 3 to 4 feet while ascending the tower. And the belay device will arrest the individual's fall if a fall should occur.
Now, does the device do it automatically, or does the attendant need to automatically act on the ID?
The device will arrest the fall automatically. The attendee attends the belay device to ensure that the rope carries through as they ascend the tower.
Once the first man up has reached the top of the tower, he can drop a life safety line such that we have here. Once the life safety line has been dropped to the ground, the rest of the crew members can climb the tower in the same fashion that they have over the years, except using a mobile life safety line such as this. The Petzl ASAP rides up and down the line as the climber climbs or descends, giving the climber full motion and control on the tower. If the climber does have a fall, the ASAP locks up instantly and prevents the climber from falling. Here we are, we're up on the bridge of a 345 kV dead-end tower. With me is James. James is going to show us a few things to consider when we're in the bridge, when we're looking at new 100% fall protection requirements. You'll notice we're wearing our full body harnesses. You also notice that we have Y lanyards attached so that we're 100% attached. Behind me, you notice James is 100% attached as well. Really the question here is how do you move around the tower while remaining 100% attached? So James, if you kind of demonstrate for us sort of the equipment that we have and how we're going to have to work in the bridge at this time.
Okay, so what I have is a Y lanyard, and with the new OSHA rules, you're going to have to maintain 100% attachment while transitioning bridges on towers. So one option is to have 2 big pelican hooks set into your Y lanyard that you can transposition onto the steel members as you work your way across. Now, let's say these hooks are so big that they're not going to make it over larger size steel. Another option to use is to take a small swing with your Y lanyard and to hook your Y lanyard. Obviously you'd probably need 2 of these for a transition onto the bigger steel, and you can work your way across using that.
And that's important because although this is a 345 dead-end tower, the 500 dead-end towers can have 6-inch angle members, and none of the current hooks that have a gate-rated strength with the ANSI stamp on them are manufactured right now. So we're going to have to go with a tieback method on the larger types of steel. Additional things to consider here is when you're working in a fall arrest mode, that means we cannot fall more than 6 feet according to the new OSHA standards. So now you have to think about most of the anchors behind you now have to be in to where they're essentially over your head and not down at your feet. So in this case, we want to also talk about work positioning up here. Work positioning we've traditionally used on the horizontal surfaces, and that was with our secondary points of attachments or our skids. James is going to demonstrate what we've been using for a work position system up here prior to the new rules. As you notice in a work position mode here, OSHA now requires that if we use work position, it has to be rigged so you can't fall more than 2 feet. And in this case, if you're looking at the steel, he can fall more than 2 feet. The second point to mention is that OSHA specifically mentioned in the preamble that work positioning now is going to be inappropriate for horizontal work surfaces, and they even mention cross arms as a horizontal work surface. So what that means for us at Western is that we have to be in fall arrest mode as we're working and walking on the horizontal surfaces on the tower arm, also back in the bridge. The issue here is we can still use work positioning for our lean out so we have our hands free, but we still must have some type of attachment here that remains 100% across the lattice members. Another item we need to consider up here is where do we actually put these attachments to be 100% in the lattice. The question is every single piece of lattice member the same when it comes to a fall arrest anchor? So James, what are some considerations we need to think about when we're looking in the bridge here, specifically with all this lacing? Is there anchors that are appropriate and others that aren't?
Absolutely. So even though this is a single bolted member, we also have to consider feasibility from OSHA. I really have nothing else to attach to here except for a large dead end member here that this hook may not go over. And it's also multi-point connected with other pieces of lacing. So this anchorage here should work. One thing that you don't want to do is connect something around a diagonal to where you're going to be able to slide, because you also have to take in the total distance of the slide into your 6 feet. So if I have on a 6-foot lanyard, as Dave has on, and I slide now 5 feet down that steel, that's technically considered an 11-foot fall. So that wouldn't be allowed. Another thing you wouldn't be able to do with it, even though as well with work positioning, is put it around a vertical member that doesn't have a lacing or a catch underneath it to support it, because now this total vertical drop has to be added into the total fall arrest distance as well.
That's a good point, James. Another point to add on is that where this anchor is, if you can see on the anchor here, we have a piece of steel here, a piece of lattice out to the center where the X crosses. This is about 5 to 6 feet. There's a difference in anchorage strength if this anchor is back here closer to the pinpoint versus out here in the middle. From a structural standpoint, the anchor out here has less strength than the material back here. So we want to try to focus on keeping our anchors at the cross or an X or in a crotch of lattice rather than out here in an empty member.
If you're transitioning and using these members to decide, you will be crossing through the weakest points of your anchorages where the greatest vector will be on them. But that falls back to OSHA's feasibility rule, to where being attached to something is far safer than being attached to nothing now. Another part that OSHA talks about is work or fall restraint. This is your secondary lanyard here, which we traditionally use in work positioning, but you can use another piece of equipment as long as it meets the ratings for the other type of system that you're going to use. And for fall restraint, there is no ratings because technically there shouldn't be any fall. So even though this isn't a vertical member, as long as I can't incur any fall, so I keep this tight, I can use this work positioning piece of equipment for fall restraint, because I'm not going to allow any fall, so there should be no induced forces onto the anchorage, and therefore it doesn't require any type of engineered status or any type of minimum standards.
And that's an important point to remember, that in this position here, it's important that there is no potential for a fall any distance. So in this case here, the tension is all in his secondary. Should he lose his footing, there's no additional forces imposed on that angle member. So that's another consideration or another option that we have to work with in the bridge. The last point we'd like to consider is that when we talk about anchoring multiple people to one anchor, we want to think about our considerations there. We might want to look at other members. So for an example, on this member here, if I were to take my secondaries and attach them where James is at right now, and James attaches his secondary up here, now we have two people attached to the single lattice member. And from an OSHA perspective, this then requires that we increase the strength rating of this steel member to be able to hold two people in a fall arrest mode. In that case, 10,000 pounds. So it's important to understand that if you're going to have additional people working in the bridge next to you, that you spread your positions or your anchors out away from just one lattice member such as we have in this case here.
Safety is of prime importance at Western, and it is our goal to ensure that each employee returns home to their family the same as they started each day.
Myself and the WMMC is absolutely committed to the new fall protection effort and the safety of our employees.
People's lives are worth the time it takes to be compliant with the fall protection mandates. If you happen to have a family at home, your family is counting on you to come home at the end of the day.
I and WMMC expect full compliance with the new OSHA fall protection regulations in support of keeping our employees safe.
Thank you for watching this video. Fall protection and your safety in general is the WMMC's top concern and a matter we take very seriously. Together we can make sure that no one falls and that everyone returns home safely.